morning. How are you? Thank you. You have chosen the class for this semester. This class will be run by active and participative method. In addition, you can show or watch the video that have been prepared. Hopefully, you can follow it well until the class is over. Enjoy the day by learning metabolism. Now let's start with the first topic. The title is Introduction to Metabolism, the chemistry of life. The topic that I'll discuss this morning are human energetic and overview of metabolism. Now let's see this figure here. This chemical present in the matchstick is potassium chloride, sulfur, starch, and a glue. This chemical present on the tip of matchstick. Matchstick, the match box sticking surface contain the phosphorus, powder glass, and glue. Now let's see the energy. Energy is the ability to do work. This energy can be in several forms, include potential energy and kinetic energy. Potential energy is energy stored in an object. An example for this one is a chemical energy. Chemical energy is potential energy available to release in a chemical reaction. Kinetic energy is energy of an object in motion. For example, of this one is a thermal energy. This thermal energy is kinetic energy of atom or a molecule. Now let's see this energy is the ability to do work. Let's see this picture. Solar energy will be used by plant to convert or synthesize carbohydrate. This carbohydrate in plant will be eaten by animal. Both plant and animal will be used as a source of food. And this food will be converted into chemical energy such as ATP or other molecule such as NADH. This chemical energy need for the body. So energy in this case will use for growth, reproduction, and maintenance of the living system. Even though we discuss a living matter, we can see that this thermodynamic can be applied to the living system. Let's see this one. First law of thermodynamics is energy can be transferred and transformed, but it can be created or destroyed. That's the first law of thermodynamics. The second one is every energy transfer or transformation increase the entropy of the universe. Let's see the equation below. The equation describes the change in free energy of a system when accounting for transfer of heat. This is enthalpy and change in disorder entropy of the system. So delta G equal to delta H minus T delta S. Now let's have a look to this picture. This picture represents of highly ordered, and this one represent of more disorder. Then if we intend to compare this system from highly ordered to more disorder, then it will increase in entropy. Now let's move to give a free energy. Give free energy explain the change in free energy that occur as a result of a comparison of is represented by delta G. And not all of this energy is available for chemical reaction because during the reaction some energy will be transferred as heat. Then the last is delta G can be positive or negative. Let's see this one. This is a give free energy. The unit for this give free energy is a kilojoule per mole, and this is a step of reaction pathway. Let's see. We start from glucose. This is a glycolysis. Then this glucose will convert into a pyruvate. Let's discuss about this gives energy or give free energy. For example, this one, not all of this energy is available for chemical reaction because during the reaction, some energy will be transferred as heat. Okay. Now let's move to metabolism. This kind of metabolism is the sum of the chemical reaction that take place within each cell of a living organism and that provide energy for vital process and for synthesizing new organic material. So we can see from this picture the metabolite precursor are transformed to the end product via many specific transformation. Let's see like this one. We can imagine that this one should be a Krebs cycle, right? So if this is the ending story of our discussion, so this one can be, the starting material of this one can become from carbohydrate metabolism, lipid metabolism, and other metabolism. Now, let's have a look to metabolic pathway. This metabolic pathway can be divided into two types. The first one is a catabolic pathway, and others is anabolic pathway. Catabolic pathway is a breakdown complex molecule into simpler compound. An example for this one is amylase that breaks complex fat into simple sugar. Anabolic pathway is assemble small compound into complex molecule. For example, for this one is anabolic steroid that build a muscle. Let's see the figure below. This is anabolic pathway. A small molecule will be converted into big or complex molecule. In this case, energy is required. But vice versa, in catabolic, molecule are broken down into small one. And in this case, energy is released. Now let's have a look to ATP, energy currency of a cell. Have a look to this one. This one is a adenosine. This one. And this one, adenine monophosphate, adenine diphosphate, and this is a triphosphate. Information of this one, because this is a negative charge. So if we have this one, there should be repulsion of one each other. So in discussing this one, let's conclude that negative charge on phosphate group naturally repel each other, requiring energy to bond them together and releasing energy when these bonds are broken. So in this case, ATP is abundant of energy. Okay. Now let's move to this ATP energy currency of a cell. Let's see this one. This one from ADP into ATP, there should be phosphorylation in this one. But if we discuss from ATP to ADP, there should be dephosphorylation. In such a case, reaction that need energy, it should be used this ATP. ATP will be hydrolyzed into ADP. So in this case, energy for cellular work, we call this one as endergonic energy consuming processes. And this one From this one, energy from catabolism is exergonic, energy yielding process. Now let's move to metabolic pathway and energy transfer. In this case, have a look to this one. See this one, we have a cell here. This one has surrounding. So there are several molecules that will enter this cell. After entering this cell, this molecule will be compared into a smaller one that we call this one as a cellular building block. In catabolic pathway, this pathway will produce ATP, but a small amount of energy will be used as heat. In same cell, this cellular building block will be used to synthesize macromolecules such as protein, DNA, glycogen, fat, and RNA. For some pathway, both in catabolism and anabolism, those are amphipolic pathway. You should remember that one. Amphipolic pathway. Now let's move to equilibrium and metabolism. We discuss about closed system and open system. Closed system unable to exchange matter or energy with its environment. And this closed system will reach equilibrium. Let's see this one. This is the schematic diagram of closed hydroelectric system. Water flowing downhill turn a turbine that drive a generator providing electricity to a light bulb, but only until the system reach equilibrium. After reach the equilibrium, no more electricity got. But for open system, you can see this one completely different. This is flowing water, keep driving this generator because intake and outflow of water keep the system from reaching equilibrium. So there will be never equilibrium reach. So in this case, delta G is less than 0. So see this one, closed system and open system. Now let's move to this one. Cell that has reached metabolic equilibrium is the system at equilibrium are at minimum free energy and can do no work. Let's see this one. This is open system. This is boundary. And this is the surrounding. If this is open system, there will be energy or matter that can in to the system or out of the system to surrounding. Let's see this a cell. Cell is an open system. Why we should claim that this cell an open system? There's something like this. This is the cell. Let's say this is a membrane, for example. But even though they have a boundary here, but it doesn't mean this is a closed system, because sugar, protein, fat can into the cell, and carbon dioxide plus water can out of the cell. So this is open system. So once again, we should remember that cell is an open system. It's not a closed system. Now let's see exergonic and endergonic reaction. Let's see this diagram. This is a give a free energy, and this is a reaction. We will start for this reactant, and this is our product. Reactant in this is in this part. Then the product, it will be in this point. Let's see the delta of delta G. Delta G is less than 0. In this case, let's see, exergonic reaction is spontaneous. Again, delta G is less than 0. For endogenic reaction, let's see, the reaction is not spontaneous. Why it's not spontaneous? Let's see this one. The reactant, the energy is here, but the product is in this point. So delta G, you can calculate or imagine that this delta G is higher than 0. So exergonic and endergonic reaction result in change in give free energy. Now let's see exergonic and endergonic reaction. This kind of exergonic and endergonic reaction should be involved in one system. It means that, let's see this one, exergonic reaction involved in providing energy who occur coupled with the endergonic metabolic reaction. These two will be happen in one system. Let's see this one. For example, endergonic reaction, delta G is positive. Reaction is not spontaneous, right? You can see this one, delta G plus 3.4 kilocalorie per mole. Then this one, exergonic reaction, delta G is negative. Reaction is spontaneous. This is ATP hydrolyzed into ADP, and delta G is minus 7.3 kilocalorie per mole. Coupled reaction, overall delta G is negative. Let's see this one. Reaction are spontaneous. Delta G as a summation of this one is minus 3.9 kilocalorie per mole. Now let's see the step of catabolism. See this one? Macromolecule, protein, polysaccharide, lipid. Then the first one is hydrolysis of complex molecule to their component building block. Step 2, conversion of building block to acetyl-CoA or other simple intermediate. Then oxidation of acetyl-CoA, oxidative phosphorylation. This is the step 3. Let's see this one. Macromolecule convert into building block, and this building block convert into acetyl-CoA, and this acetyl-CoA will enter the Krebs cycle. This is the step of catabolism. Now then, let's see the step of anabolism. Step 1 is production of precursor such amino acid, a monosaccharide, isopronate, or nucleotide. Second step, activation of this precursor into reactive form using energy from ATP. And the step 3 is the assembly of this precursor into complex molecule such as protein, polysaccharide, lipid, and nucleic acid. Let's see this one. This is a simple compound. Let's say like carbon dioxide, urea, ammonia, lactic acid, and ethanol. And this precursor will be used to produce complex nutrients such as carbohydrate, protein, and lipid. In this case, they need, this reaction need energy from this ATP. So it means that this one energy requirement provided by ATP hydrolysis. And this is anabolism. Now let's see the time of what is a metabolite, metabolic reaction, and metabolic pathway. Metabolite is a substrate or a reactant undergoing a biochemical or metabolic reaction. Metabolic reaction is biochemical reaction where a metabolite is specifically react by an enzyme and coenzyme or cofactor to give a product. Metabolic pathway is a series of well-defined and significant biochemical reaction follow one after another, giving intermediate product and finally end product of the pathway. See this one. Then let's see several types of biochemical reaction. Oxidation, dehydrogenation, hydroxylation, reduction, hydrolytic, carboxylation, decarboxylation, phosphorylation, dephosphorylation, amination, deamination, isomerization, hydration, and dehydration. There are so many type of biochemical reaction. Then major metabolic pathway. Let's see this one. Glycolysis, citric acid cycle, and oxidative phosphorylation, pentose phosphate pathway, gluconeogenesis, glutamine metabolism, glycogen synthesis and degradation, and fatty acid synthesis and degradation. So that's the kind of introduction of metabolism. I think that's all for this morning, our discussion. I do hope you can enjoy the class. Thank you so much. Stay safe. Thank you and see you then. Bye bye. Thank you.